let's continue on this section on radioactive decay of the elements to talk about the very radioactive places in the world. We're going to go to this website here, and we're going to take a look. It says 10 most radioactive places on Earth. It's not really the 10 most, it's 10 of the most radioactive places on Earth. And they can generally be classified into a few different categories. Okay, the top two, you should know one of them. One of them is Chernobyl. So there are nuclear disasters. There's only been a few places where nuclear disasters have ever happened. There's a couple in the Soviet Union, Fukushima in Japan, and there's a couple in the US early on that were kept quite secret. And like 3 Mile Island was not one that was really kept secret, but early on in nuclear development, some of them were kept very secret. So nuclear disasters at plants. That's one of the categories. Another category is unauthorized dumping of nuclear wastes. We'll see what that looks like in the map. You know, they take nuclear waste from power plants. Instead of dumping it someplace good, they dump it someplace bad. Nuclear test ranges. These are places where nuclear weapons were tested. I mean, the United States tested a lot of their nuclear weapons in the deserts of Nevada and then out in the small islands out in the Pacific, in the middle of the Pacific Ocean, away from everybody. So those didn't contaminate a lot. The Soviet Union tested a lot of their nuclear weapons in the deserts of Kazakhstan, which did cause quite a few problems. These are kind of the three main ones. There's also some old, unsafe nuclear production. Right, places where they made things like plutonium or enriched uranium for nuclear power. When they started doing that back in the 40s and 50s, they were not always the keenest on safety. So let's go take a look at this website. It's right here. 10 of the most radioactive places on Earth, and you can see here on this globe. There's a bunch down there in Africa. There's a bunch in the Mediterranean. This one in the middle is Chernobyl. There's Fukushima. That was the most recent nuclear power plant due to a tsunami. There's some in Central Asia. Those are where the Soviet Union tested nuclear weapons. There's one there in the US. So let's take a look at a few of them. All right, there's a great cartoon, nuclear waste coming for the children, because nuclear waste lasts a long time, right? It doesn't degrade, doesn't decay that quickly. So nuclear waste can last a really long time. So I thought there was actually a list here. So covered in the map, there's Hartford. Let's see if this is the page. So Hanford, USA. Hanford, USA was where they were producing plutonium for the original nuclear weapons that the U.S. used on Hiroshima and Nagasaki. Plutonium is very radioactive and very dangerous, and that's what the Hanford site was about. The Mediterranean Sea. There's been reports that the Italian mafia, if you read this, takes money and dumps garbage in the Mediterranean Sea without anybody knowing about it. Some of that garbage is supposedly nuclear waste, and they're dumping it in there without anybody knowing about it. So if a small country wants to get rid of some nuclear waste, they don't want to go through all the hassle of making secure, safe facilities. You just give it to the Italian mafia, and they'll dump it out in the sea for you. Likewise, they do that along the Somali coast. So there's stories of that various organizations, various groups have been dumping nuclear waste material around the Somali coast around Africa. So there's the Mayak Chemical Combine, so it's an industrial complex here, it says, and it had a nuclear power plant early on in the 50s. There was an explosion early in the 50s that was kept under wraps because in the early 1950s, this was in the middle of nowhere in Russia. They could keep it secret, unlike the Chernobyl disaster, which was closer to Europe. Sellafield in the UK. So it was a plutonium production, another plutonium production plant, this time in the United Kingdom. And it was early in the United Kingdom and was releasing radioactive material into the Irish Sea, where it stays there for a long time. So another one in Russia, a Siberian chemical factory, which dealt with nuclear waste. The polygon in Kazakhstan, you can see that man's tumors. The polygon in Kazakhstan, polygon is the place where they test out their nuclear weapons. People lived there. So it says here 456 tests over 40 years. And there was hundreds of thousands of people who lived in the area. Here is a mine in Kyrgyzstan. And so they mined uranium, they processed the uranium there. They didn't really do a great job of preventing the radioactive material from getting into the natural ecosystems. Of course, there's Chernobyl, Ukraine. Says here that in Chernobyl, Ukraine, a lot of the radiation went to Belarus, which is a country just north of Ukraine. And so a lot of the cancer issues, and you can see that child has some severe cancer. That is one large tumor. A lot of the cancer issues were more in Belarus than in Ukraine itself, so just to the north. And there's Fukushima, Japan, which is where an earthquake caused a tsunami to hit a nuclear reactor. A lot of the radiation went to the sea. A lot of it's been contained, but it remains a very radioactive place on Earth. All right, so those are some of the very radioactive places on Earth. Now let's take a look at the effects of radiation on living things. Okay, so sunburns. So the biggest thing we have to remember is that ionizing radiation causes electrons to leave atoms/molecules. This can damage chemical bonds. Okay, so in sunlight there is ionizing radiation sunlight. The primary is UVA and UVB light. Now, if we look up here, if we remember black body radiation, right? So right here, visible light out this way, this is non-ionizing radiation. This is the ionizing radiation that the sun produces and sends to us. Not a lot of gamma radiation, not a lot of X-ray radiation, fortunately for us, but UV radiation mostly. Now, a lot of the UV radiation is absorbed by the ozone, but some still gets through. Now, some of this is helpful. UVA radiation causes us to produce vitamin D. So you go out in the sunshine and your skin has chemicals in it that produce vitamin D from being hit by sunlight or UVA radiation. UVB light causes, this is the one that causes more damage. And how does the UVB do that? Well, the UVB radiation enters your skin cells and can break up molecules in your skin cells. So what it mostly damages is it damages the DNA. DNA is a huge molecule. So you get these UVB light, this UVB radiation coming from outside, and it will damage your DNA. Now, that's bad. So when the DNA is damaged, so once the DNA is damaged, hopefully the cell detects the damage and commits suicide. So cell should detect and commit suicide. In other words, the cell has a mechanism in itself to understand that, hey, I'm damaged, I need to die, I should not be replicating anymore. So the DNA is damaged, the cell should detect that damage and then stop working, it should die off. Okay, this is essentially what a sunburn is. Sunburn is a whole bunch of your skin cells detecting that they've been damaged by the UVB light, and they are dying off. That's a sunburn. Right now, your skin does have some mechanisms to prevent this DNA damage, and that is what's called melanin. Melanin helps protect against UVB radiation. Melanin is what causes a suntan. So after you have a sunburn, you have some people have cells in there, and they will produce more melanin. That melanin will go into your skin, you'll get suntanned, and that darker melanin in your skin helps absorb UVB light so it doesn't damage your cells. It's one of the reasons why people who are outside in hot climates all the time have naturally darker skin than people who live in colder climates where there is less sunlight, less UV radiation. So melanin helps protect against UVB. Now, what happens if that DNA is damaged but the cell doesn't die, but the cell replicates and has some errors in its replication? Well, cancers are what happen. Cancer cells have some damage. That cause them to replicate. Without proper limits. This DNA damage can be caused by radiation. It is rare. right? You don't get cancer every time you get a sunburn. You can get hundreds of sunburns and not get cancer from it because most cells do this. Most of the time, the cells do this. They detect the damage, they stop trying to replicate, and that's it. But every now and then, every once in a while, the DNA damage causes the cell not to die, but to have this mutation in it where it replicates not without the proper limits that are set on by normal biology. And then it'll keep replicating, creating tumors and cancer cells. All right, so ionizing radiation can cause DNA damage, and that DNA damage usually causes cells to just die. But sometimes that DNA damage does not get picked up by that mechanism and can cause a cell to replicate without proper limits, and that's what causes a cancerous tumor. You have a cell that's not really following the proper instructions anymore, and it's just replicating and replicating and replicating. Now, remember, this cancer stuff has to be caused by ionizing radiation. Cell phone signals and microwaves are not ionizing radiation. So they don't cause cancer. They don't cause DNA damage. All right, so we saw acute radiation poisoning in the Chernobyl video. And acute radiation poisoning was generally caused like symptoms like nausea, vomiting, diarrhea. And there's some other ones. I'd probably spell diarrhea. And then there's a latency period. And he didn't know how long that latency period went for. It could go for a while. So you felt sick, just kind of like your normal sick. You got nausea, you got vomiting, you got diarrhea, you probably have a fever. You feel this sick. And then there's a latency period. And after that latency period, okay, what's happening is, well, those cells are figuring out what to do, because there's a bunch of cells inside of you that have damage to their DNA. And those cells are, well, deciding whether or not to die off. And then you have a latency period, which is followed by massive cell die-off. And this is what's called the burns. Right? They're not actually burns, like they're not from fire, from burns. It hasn't burned from heat. It is just the cells are dying. And they're wasting away. So you can see here, when these cells start to die off, well, I mean, it can just be burns like you saw in the video, right? Some of the muscles, like down to the bone, was just, there's no cells. So it's all damaged all the way down to the bones. It will damage inside, causing like internal bleeding, problems with your lungs. It can cause lots of issues. So this is acute radiation poisoning. You get a high dose very quickly. Radiation sickness can cause a whole bunch of other symptoms here. And right, you have to understand that there's a difference between acute radiation poisoning, which happens a lot of radiation quickly, that's why it's acute, and then things that can happen like seizures over long-term radiation poisoning, where you have lots of little damage that kind of builds up over a long time. So you can take a little bit of damage and be fine, but it builds up. So you get things like this. Loss of white blood cells, increasing risk of infection. So internal bleeding. So little damage inside you can build up over a long term with long-term radiation sickness. All right, so you can see here what the effect of ionizing radiation is on on living things. Mainly is that it has a good chance to damage DNA structures inside your cells, and that DNA damage generally leads to cells dying off because cells have a mechanism in them to do that, or it can lead to cancer cells if the die-off mechanism doesn't work properly. All right, so that's going to end this section on radioactivity and nuclear decay, and you are going